Good morning to all. I am Prabhake, working as Assistant Professor in the Department of Electronics and Communication Engineering, Sai Vidya Institute of Technology, Bengaluru. Today we'll discuss about logical shift and rotate instructions, which is one of the topic in the Module 2 of Computer Organization and Architecture subject. First, we'll discuss about logical shift instructions. In many applications, we come across that the bits of an operand needs to be shifted either towards right or left with a known number of shifts. For this purpose, we use shift instructions. There are two types of logical shift instructions. Logical shift left instruction, logical shift right instructions. These instructions shifts the bits in the destination operand by one or more positions either to the left or right. Whatever the bits which are shifted out of the register will be lost. The syntax of these instructions mainly consists of an opcode, destination operand, and the number, that how many times the shift needs to be executed. If this number is 1, only one time the data of the destination operand is shifted either towards left or right as specified in the opcode. Another syntax consists of opcode, destination, and the account register, which gives how many times the shift has to be performed. In these instructions, the destinations can be an 8-bit or a 16-bit register or a memory variable. First, we analyze the logical shift left instructions. Logical shift left instruction shifts an operand content towards left over a number of bit position specified in a count operand contained in the instruction. Here, with a general notation, we can analyze. Consider an instruction L shift L count, destination. Here, L shift L is an opcode which tells that logically shift towards left by the amount or by the shift number given in this count, and the shift operation is performed on the content of this destination operand. Here, the count can be an immediate operand or it may be contained in processor register. This example here, L shift L hash 2, R0. L shift L is an opcode for a shift left operation. Hash 2 gives the number of count, that is how many times the shift operation is required to be performed or how many shifts number is required to be performed on the given operand of R0. Consider a register R0 which is of 8-bit and initially it consists of a content given, taken as an example 11110011, 11110011 is the content of the R0 register before the execution of shift left instruction. Here, two times the bits are shifted towards left. So, the content moves from LSB towards the next higher MSB. Like that, the shift operation takes place. The MSB will be shifted to the carry and it will be lost. A copy of the MSB bit will be present in the carry flag. This is one time shift. As the count is 2 here, the another time shift operation performs. Whenever a data moves from the LSB to the next higher MSB bit, the LSB will be filled by zeros. Like that, after two shifts, the R0 contains 1110 1100 1100. Now we'll analyze logical shift right instructions. This instruction shifts an operand content towards right over a number of bit position specified in a count operand contained in the instruction. The general notation is given by L shift R, logical shift right, count value, destination operand. The count can be an immediate operand or it may be contained in the processor register. L shift R hash 2, R0 is an logical shift right instruction where the how many times the shift has to be done on the operand content is specified in the count. Here it is 2 and the operand considered here it is R0. Here the R0 contains the sum value. Before the execution, this is the content of the R0. After first shift, the content from the MSB will be shifted towards right by bit 1 position. The content of LSB is moved out and a copy of that will be available in the carry flag. After second shift, the data is once again moved from MSB towards the next LSB and the empty bit positions are filled by the new zeros. And the bit which is moved out of the register will be lost and the copy of the last bit moved out will be available in the carry flag. Next instruction is arithmetic shift right instruction. This instruction shifts an operand towards right over a number of bit position specified in a count operand contained in the instruction. An arithmetic shift fills newly created bit position with a copy of number sign bit. This MSB bit is retained as original. The general notation is given by A shift R, arithmetic shift R, count, destination operand. The count can be an immediate operand or it can be contained in any of the processor register. Example here, A shift R hash 2, R0. A shift R is the opcode for arithmetic shift right operation. Hash 2 gives the count value and the destination operand is considered here is R0. The pictorial representation, it is very clear that the R0 is considered as an 8-bit register, C is the carry flag and the B7 is the MSB bit. The initial value of R0 is 410011. After the execution of this instruction, that is after first shift, the content of R0 is shifted towards right by 1 bit position, but you can make out here the MSB value is retained as 1 instead of storing new zeros here. The bit which is moved out of the register from the LSB will be lost and the copy of that will be present in the carry flag after the first shift. After the second shift, the same thing is continued. From the MSB, the bits are shifted towards the right by 1 bit position and the LSB bit is lost and the copy of this will be available in a carry flag, and you can make here the MSB bit is retained as it is. The arithmetic shift left is identical to the logical shift left operation. The next we'll analyze the logical rotate instructions. In rotate instruction, the bit shifted out from one end of the destination operand is put back on the other end. The syntax consists of an opcode, destination, comma 1. One gives here count value. Opcode will specify the type of rotate instruction, and the destination operand is the one on which this actual logical rotate operation is carried. Opcode destination comma CL, here the CL value gives you the number of times the rotate operation is need to be carried out. Where the destination register can be an 8-bit register, or it can be a 16-bit register, or it can be any memory element. Or the opcode can be of this format also, opcode hash n comma destination, where hash n indicates the number of count the rotate operation is need to be performed on the destination operand. Logical rotate left instruction. This instruction is used to rotate the content of a register towards left by one position or more position as defined in the instruction. The highest bit is copied into both the carry flag and also into the lowest bit. No bits are lost in rotate instructions. Example, ROL hash 2, R0. ROL is an opcode, rotate left, hash 2 is a number of times the rotate need to be performed on the destination operand R0. Logical rotate right instructions. Here, this instruction is used to rotate the content of register towards the right by one position or more position as defined in the instruction. The lowest bit is copied into both carry flag as well as it is moved to the highest bit, that is MSB bit. No bits are lost. Example, ROR hash 2, R0. ROR is a opcode, rotate right by 2 position of the content of destination operand R0. You can make out here the R0 contains this data. After one shift, the contents are moved towards the right from MSB towards the LSB, and the LSB content is moved to the carry flag, and the copy of this is also present in the MSB bit. Another way, the LSB bit is moved to the MSB bit. Like this, 2 times the rotate operation is carried out because the count is here 2. Logical rotate with carry. This instruction is used to rotate the content of register towards left by one position or more position. The highest bit is moved to the carry flag and the carry content is moved into the lowest bit, that is LSB. Once again, no bits are lost. Example, RLC hash 2 comma R0. RLC is rotate left with carry, and 2 gives the number of count, and R0 is the destination operand. You can make out here the content of MSB is moved to the carry. Like that, every bit is moved towards the left, and the content of carry is moved to the LSB. Similarly, after the second shift, the MSB bit is moved to the carry. Next bit is moved to the next higher bit. Like that, bits are moved towards the left, and the carry bit is moved to the LSB bit position. Logical rotate right with carry instruction. This instruction is used to rotate the content of register towards right by one position or more position as specified in the instruction. The lowest bit is moved to the carry flag, and the content of carry is moved to the highest bit, that is MSB. Once again, no bits are lost. Example, RRC hash 2 comma R0. RRC is opcode for rotate right with carry by how many times? Count value is 2 here on the content of R0. Consider the content of R0. After the execution of this instruction, the content of R0 is moved towards right with carry, such that the LSB is moved to the carry flag and the carry flag content is moved to the MSB bit position. Thank you.